This is the final project for computer graphics. I am Priyanshu.
I'm Andrew.
I'm Miss Frank.
Um, so the algorithms implemented are L system, cellular noise, and spotlight using Phong shading. This was the original idea.
Yeah, so basically the idea is we have a single plant, and then we have a spotlight on that plant, and the plant is growing through concrete. So the plant generates the L system, spotlight, and then we have the noise, which is generating concrete, and then a brick wall in the background.
And then the idea that we want to show is perseverance of the plant, and that ties into the theme of journey.
These are the final images. So you can see a small plant growing larger and larger, going through the cracks. This is the theme view. This was our artistic theme. Uh, this is a video.
So as you can see, a plant is going through the concrete pavement, breaking through what seems to be an impenetrable barrier, showing perseverance and never giving up.
Yep, you can see the spotlight on the plant right here. The cracks were generated using cellular noise, and the plant itself was generated using L system.
Yeah, so essentially every iteration of the this video stopped, but every iteration of the L system is represented here. So yeah, up to 4.
We have 4 stages for the L system.
Okay, so one of the challenges we faced when implementing L systems was how to make it 3D. So originally when we were calculating the L system, we stored the current state as the current position and also the rotation angle. But we had to change this so that we store the direction axis instead of the rotation angle, so that we could draw in an arbitrary direction. And so as you can see from the image, we used to have like an angle. So we draw from like 90 degrees to 45 degrees. But then in 3D, now we can store an axis. So that means we can draw it in any arbitrary direction. So originally we have like 0, 0, 1, and then now we want to draw in a different direction. So we change the axis and draw in a different direction.
This was a spotlight. So this was my inspiration for the spotlight. As in the video, you can see it's not coming directly. It's coming like the sun's light. It's not directly above, but at a certain angle. The challenges were to adjust the ambient, diffuse, and specular coefficients for a realistic appearance, and then combining the cellular noise for a better visual appeal. And the spotlight itself was simulated using Phong shading and cellular noise integration.
To create the cracks, we use an advanced noise algorithm known as cellular or whirly noise. And a challenge I faced was finding the right balance between scaling noise that resembles realistic cracks. So if the scale was too high, the cracks would be too small and too dense. On the other hand, if the scale was too low, the cracks would be too big and far apart. And going either in either direction would be unrealistic for cracks. So getting the right balance required a lot of fine tuning.
Thank you.